This is A-Level Mathematics Paper 1, Year 2013, Question 5. There are two parts to question 5. We look at the first part. You are asked to prove a trigonometric equation here. Sine theta over sine theta plus cosine theta plus cosine theta over sine theta minus cosine theta. That equals the reciprocal of sine squared minus cosine squared. In order to prove an identity, we start either from the left or from the right. In this case, the left side is more complicated than the right side, so it would be easier to just start from the left side. Now for this left side here, you start with sine theta over sine theta plus cosine theta, and you have cosine theta over sine theta minus cosine theta. On the right side, there's only one term. On the left side, there are two terms. You need to make a common denominator. So in order to make a common denominator, you multiply the first term by the denominator of the second term, meaning that you have sine theta, you multiply this by sine theta minus cosine theta, which is the denominator of the second term. And for this case here, the denominator, you have sine theta plus cosine theta, which is multiplied to sine theta minus cosine theta as well. For the second term, you multiply both the numerator and the denominator by the denominator of the first term, which is sine theta plus cosine theta. So you multiply cosine theta by sine theta plus cosine theta and do the same for the denominator. Now let's look at the numerator. For the numerator here, for the first term, when you expand the numerator, that gives you sine squared theta minus sine theta cosine theta. And for the second term, you add 2 cosine theta sine theta plus cosine squared theta. The denominators are common, so you only need to write once. Now let's look at the denominator. You have sine theta plus cosine theta and sine theta minus cosine theta. This is actually the difference of squares, whereby you have a plus b and a minus b, and this is given by a squared minus b squared. That is the factored form of the difference of squares. So instead of distributing term by term, the denominator is just sine squared theta minus cosine squared theta. Now let's look at the numerator. You have sine theta cosine theta minus sine theta cosine theta. These two cancels off. So you are left with sine squared theta plus cosine squared theta all over sine squared theta minus cosine squared theta. The numerator sine squared plus cosine squared, this is actually 1 from the fundamental identity of trigonometry. So you have 1 over sine squared theta minus cosine squared theta, which is the right side of the equation that you are asked to prove. That is question 5, part 1. Question 5, part 2, hence solve this equation. Now you look at the left side here of this equation for theta in between 0 and 360 degrees. When you see the word hence, it means you need to use the result from the first part. From the first part, you have, this is the left side of the equation you are asked to prove from the first part, and that is actually the reciprocal of sine square minus cosine square. So we are going to replace the left side by the reciprocal of sine square minus cosine square into the equation. The equation becomes the reciprocal of sine square minus cosine square, and that is 3. Now, upon rearrangement, you can actually take reciprocal on both sides so that sine square minus cosine square, this is now 1/3. Your sine square and cosine square, you need to make this in terms of either sine only or cosine only. Now, from the Pythagorean theorem or the fundamental identities of trigonometry, you know that sine square plus cosine square is 1, so that cosine square is 1 minus sine square. So this cosine square can be replaced by 1 minus sine square. In that case, you have sine square theta minus. Now, remember you need a bracket here because of the negative sign. Otherwise, the answer is just going to end up wrong. And that is 1/3. So distribute that. You have sine square theta minus 1 plus sine square theta equals 1/3. Rearranging, you have 2 sine square theta equals 1/3 plus 1, which is just 4/3. Isolate sine square, so you divide throughout by 2, so that sine square now is 2/3. And taking square root on both sides, you have sine theta equals plus minus square root of 2/3. If you are taking square root, you need to add a plus minus here. So sine theta is plus minus square root of 2/3, meaning that there are 4 solutions to this equation. The angle theta spans all 4 quadrants. Because sine is positive in the first and the second quadrant, it is negative in the third and the fourth quadrant. Find the principal angle. So now we need to find the principal angle that is given by inverse sine of square root of 2/3. And this principal angle can be obtained from your calculator. That gives you 54.7 degrees. The angle that you need now is 54.7 degrees. This is a quadrant 1 angle. In quadrant 2, you have 180 degrees minus the principal angle, 54.7 degrees. That will give you a quadrant 2 angle. That is a quadrant 1. For quadrant 3, you have 180 degrees plus 54.7. That is quadrant 3. And quadrant 4, you have 360 degrees minus 54.7 degrees. That gives you a quadrant 4 angle. So theta now is 54.7 degrees, 125.3 degrees, 234.7 degrees, and 305.3 degrees. That will give you the answer for the equation. Always remember that if sine theta is positive and negative, then theta spans all 4 quadrants. You should have 4 solutions. If sine theta is positive, then your answer, the angle theta, is in quadrant 1 or 2. If sine theta is negative, then your answer theta is either in quadrant 3 or quadrant 4.